Students, this is the help video for the ALEKS portion. This is not every single question help video, but the ones that students in general find sometimes a bit challenging. So this one in particular says the sum of the interior angles of a convex polygon is 2340. How many sides does it have? A couple clues here. When you see the phrase polygon, it means you don't know the n. You don't know what the number of sides are. That's why it asks how many sides. So your n is unknown. That is here is an equal sign, so something is 2340. And what is that? It is the sum of interior angles, sides minus 2 times 180. And you just take it from there. Two things you could do here. You could either distribute the 180 and work it from there, or I'm going to divide the 180 out completely. And I'm not going to distribute it at all. So I have, by 0, so I have 234 and 18. I'm going to divide both by 6. So I know 6 goes into 18 3 times. 6 goes in there. Let's see, that's going to be 2, 3, 4, 6, and 3, 18, 54. I've got 39. 39 divided by 3 is 13. So I have n minus 2 equals 13 plus 2 plus 2. So our number of sides here is a 15 gone. Says that we have a convex polygon with 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. It wants you to find the measure of this last angle. Now, this was a triangle. It's so very easy. So that's 60, 58, and x. You know that you would solve with a triangle because triangles always sum 180. We just add and take it away. So the question here is, what is the sum of interior angles? And the sum of interior angles is sides minus 2 times 180. Your number of sides here is 8. So I have 1,080 here. So I know that's what the sum is, just like triangles add up to 180. Now, very carefully, by hand, I'm going to add these up. I have 127, cross it out as we go, 140, 118, 153, 156, 117, 134. That's 15, 16, 17, 18. 18 plus 6 is 24. 24 plus 7 is 31, 35. Carry the 3. That's going to be 5. That's 9, 10, 20, 21, 24. Carry the 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 945, 1,080. 945 minus borrow 5, 3, 1. Congratulations, you just found it. So when you feel like you're stuck, you ask yourself, what piece of information do you wish you had? And then ask yourself, how do you find that piece of information? It says right here, the measure of each interior angle of a regular polygon is 135. Find the number of sides. Once again, when you see poly, that means your sides are unknown. Your number of sides is unknown. So ask yourself, what is 135? It's a single interior angle, and very important, it's regular. So the song goes, each angle of a regular polygon, sum over sides, ain't this fun? So each angle of a regular polygon is sum over sides. Ain't this fun? Which sum? Interior. So that is n minus 2 times 180 over number of sides n. Boom. And you're told that it equals 135. Pop that over 1. We're going to cross multiply. Oops, oh, got my cross multiply this way. So we have 135n. I'm going to distribute that 180. 180 n minus 360. Your goal is to solve for n here. That is 8. It is an octagon. If you don't know that, it's 8 times 45. And it's going to be 0. Carry the 4. That's 32. 36. Check. All right. So we know the number of sides here is n equals 8. You got a rectangle below. I'm going to color code this here. We know JN. JN is that algebra. 3x plus 5. JL, which is the whole thing, is 5x plus 15. And you're given NKL. NKL. Shoulder, elbow, wrist. NKL. Shoulder, elbow, wrist. And you sweep at the elbow. So I know the elbow is going to be K here. And that is 30. I'm just going to go ahead and do the angles first. It's easier. So you ask yourself what's true about a rectangle or right angles. Also, it's a midpoint, and the lengths here going both directions are equal, which creates 4 isosceles triangles. So you just walk it around. So if that's 30, this is 30. Armpits of the Z, that's going to be 30 there and 30 here. See, armpits of the Z. And then the 90, take it away, and you're going to end up with, of course, 60 and 60. Armpits of the Z again, going that way. 60 and 60. Don't forget the interior angles. If I tell you to find everything, 30 and 30 is 60. Take away from 180, it's 120. 120, and of course that's 60, that's 60. Good, you're done with the angles. Side lengths here, ask yourself what's true about the blue and the green. And we know it takes 2 blues to make 1 green. 2 blues to make 1 green. So 3x plus 5 plus 3x plus 5 equals the 1 green, 5x plus 15. Like terms. Very important. Most likely, ALEKS is not going to just ask for X. It's going to want you to do something with it. Let's see what it asks for up here. Oh, surprise, surprise. This time it wants X. That's totally fine. So X is 5. Most of the time it's going to want you to plug in and find something. And we want here NLM. NLM. And of course, this would be 60. Already have it. If you just go ahead and find everything, you'll always have what you need. All right, so for this one, you're given some coordinates here. I recommend you put your coordinates on a diagram, sketch it, so you'll be provided a grid. -1, +6, K, -6, -2, M, 7-1. Yes, sir. What's up? No, don't apologize.
So for this one,
Yeah.
I finished this up and then I was a little confused on this. So which of the polygons from each,
Okay, so you just did that today.
yeah,
Okay, so how did you get a single shape to tessellate?
it would add up to 360 degrees.
Right, so you have to look, you have to choose the one in which the corners would add up to 360
So
by
I
itself.
chose hexagon, pentagons.
If you pentagon would be 108, 108, 108, is that gonna add up to 360?
No,
No, so a pentagon by itself does not
I
tessellate.
see what you're saying.
Yeah.
So then
The square would,
square root,
the hexagon would, you're right. And an equilateral triangle will, because it's 60. So those three will by themselves.
gotcha.
Yes,
So then triangle,
equilateral triangle specific. You can add it at the top.
how do I spell equilateral? Equal,
Equal lateral. Yes,
lateral triangle,
be concerned when you're tutoring with your mom. Not with me.
hexagon,
Yes.
square, and equilateral triangle.
And that's it.
Explain, show your math.
So what's the math? What's the math? 120 plus
120
plus
120
equals,
360.
there we go.
120 times 3. Can I see that?
That's
360.
the hexagon, so that's square. Yeah.
Square 90 times 4 equals 360. Square.
Yeah.
Triangle. Equilateral.
Yeah, there you go.
Equilateral triangle 60 times 6 equals 360.
There you go.
Oh, okay. So then for this one, which
Okay, so now I want you to just draw one.
Oh, okay.
Draw one, just one. Right. It's kind of like exactly, this is exactly what you did. You can do that.
And then yeah.
You just- There you go.
Okay, right. I'll draw that in.
Yeah.
24 polygon. So which combination of regular polygons could form a semi-regular tessellation? I don't think I would do this.
Well, let's figure it out. Again, you're looking for adding up to 360. So your 24 gone is 165. And where's your 12 gone? What'd you get for your?
Oh, shoot. I'm pretty sure 360 minus 1,800.
It's not terms, it's times.
Yeah.
Sorry.
180. Okay, and then divided by 144.
Right by 12. It is 144. It's not
No, wait, this is dodecagon.
dodecagon.
Oh, I thought that was 10.
No, it's not 10, it's 12. Dodecagon.
Dodecagon.
Yeah.
So then we do 12
Minus
minus
2.
minus 2.
That's
10 is 1,800.
divided by 12. Yes. 12 goes in there. And goes in one time.
Hang on, 12 does go to 18 once, yes, keep going. Which one goes in 16,
150.
150.
150 degrees.
okay,
Is that correct? Okay.
okay, let's check. Could you add 165 and 165, please?
Uh, 330. That
Okay, so
does not equal 360.
correct, so 330, but, so 330 and there's only 3 left, so see if it combines with anything else. Because here you have 150, right? What's 150 plus 150?
300.
300. There's a 60. So a dodecagon and an equilateral triangle combo would work. Do you see that?
I see.
So there's a couple combos here that would work.
And I need 2 or more. I need
At least-
all of them.
No, I'm not, that's right.
You
Okay,
know-
I want at least 2 examples.
Oh,
There's, I just, so that you know there's more than one.
got you. And then I show them.
And
Thank
then-
you.
yeah.
Thank you. Got you.
All right, so taking a look here, and it says it wants the length of JK. JK length. It's right here. JK is going to be -6 and -1. -2 and 6. Double negative makes a positive. That's going to be 25 plus 64. It's going to be square root of 89. And then next to, adjacent to means next to. So you could either do JM or KL. I'm just going to do KL. So K2L, y minus y, -2 minus -7, x minus x, -6 minus 2. That's going to be 5 and 25 again, and that's 8, so it's 64 again. It's root 89. Slope of JK, y minus y, x minus x, slope of what's next to it. So for JK, y minus y, that is 6, -2, x minus x, -1, -6. It's 8 over, double negative makes a positive, 5. We would expect it to be positive because it's going up from left to right. And then we're going to go this way, so -2 minus -7. It's going to be positive 5. And then 6 minus 2. Excuse me, -6 minus 2, that's going to be -8. So we have here 8 over 5 and -5 over 8, which means they multiply to a right angle. And then earlier we found that they are equal distance. So that is going to make this whole thing a square. How do I know it's square? Because it says it's already a parallelogram. So what does it qualify as? If it qualifies as a square, it already qualifies as a rectangle because rectangle just has the right angles. And it also qualifies as a rhombus because a rhombus has congruent consecutive sides. So heads up, if you check square, the other two are automatically equal. Here we are. We have on a coordinate plane, you have point X, and X is at 2, 3. And you have point Y at 4, -1. And you have Z at -1, +7. So it is a very squishy triangle here. And it says that you translate this X point to, translate means to slide around 3, 4, so over 3, or to the point 3, 4. So we're going from 2, 3 to 3, 4. So notice what the translation is here. That's X prime. So from 2 to 3, that is a +1. And then from 3 to 4, that's also a +1. So to each your X coordinates, you're going to add 1, add 1, add 1. And to your Y coordinates, you're also going to add 1, add 1. So if I wanted Y prime, -4 + 1, that's 5. -1 + 1, 0. Z prime, -1 + 1 is 0. 7 + 1 is 8. And if you wanted to graph those, you could just to see, and it was the same image, but just slid over. Rotate the following 90 degrees counterclockwise. So goes like this. To rotate 90 counterclockwise, you switch and flip to the left. I'm not sure how that's recording, if that's recording left or not, but right here. So what you do is if you have XY counterclockwise, you change it to YX. And then counterclockwise is to the left. You're going to flip the sign on the left. That's the order for 90-degree rotation counterclockwise. So we have to find these 3 points. 1, 2, 5, -1, 3, 4. So 1, 2, 3, 4, and 5, -1. All right, so we're going to switch and flip to the left. So first we switch. You only do this in one step at a time. And you flip the sign on the left, flip the sign, flip the sign, flip that sign. Graph. So -2, +1, -4, +3, and +1, +5. And once again, it's a little hard to tell exactly if this has worked, so I always check a before and after. So I'm going to check this middle point here. So from the origin to that original point, and then to the new point, you check, yes, that does actually look like a right angle, and yes, we are rotating to the left. We are going to take this image, we're going to dilate by 3/2. dilate from the origin. 3/2 is bigger than 1, so we know our final product is going to be enlarged. So we get our points here, and that's going to be 6, 12. That is 6, 6. That looks to be 10, 8. Okay, so 6, 12, 10, 8, and 6, 6. All right, so for each of these, we're going to times by 3/2. So 3/2 times 6, 12 times 3/2, 10 times 3/2, 8 times 3/2, 6 times 3/2, 6 again times 3/2. It gets us our new coordinates. 2 goes into 6 3 times. 3 times 3 is 9. So wherever you have a 6, we just figured out it's 9. So we don't have to do these guys. 12. 2 goes into 12 6 times. Bring around the 6. 6 times 3, that's 18. Any other 12? Nope. We're good there. 10. 2 goes in there 5. 5 times 3, that's 15. 2 goes into 8 4 times. 4, that's 12. Start graphing your new points. We have 9 and 18. And 15 and 12. And 9 and 9. And if you've done this correctly, you have the same shape, just a different size. And in this case, we know it's bigger because it is enlarged. These are similar, same shape, different size. Taking a look here. Says we are going to dilate about the origin. So the original figure area of the original figure. So this is our original figure. And the area here, that's going to be 2 units by 8 units. So that is 16 units. If you were to dilate by 2, that means you double the edge length. So we're going to go 2 to 6. And so dilating by 2 means we double each of the edge lengths. So we're going to go from 2 to 4, 2 to 4. And here we're going to go 8 to 16. That's what dilate by 2. It's meaning we double all the edge lengths here. And if you count these squares here, we know that if this edge was 8, this whole edge is 16. If this edge was 2, this edge is 4. So 4 times 16 is going to be 48 square units. Okay, so notice what did we do here? We doubled the edge length, and yet look at what happened to the area. The 16 Okay, friends, no, 4 times 16 is not 48. 4 times 16, we'll dehide it here, 4 carry the 2, it's going to be 64. There it is. Okay. Therefore, what's happened is the area of the final figure is 4 times the original figure. So you double the edge length and the area is quadrupled. And the original and the final figure are always similar, same shape, different size. So this is what happened in the first dimension. Okay, we went from 1 to 2. In the second dimension area, we went 1 to 4. Okay, and that's because in the first dimension is x to the first, the second dimension is x to the second. So if you take 2 to the first and take it 2 to the second, it gives you 4. Draw the lines of symmetry. Ask yourself where this can be folded so that you get 2 equal sides or 2 equal congruent shapes, and it has 1, 2 lines of symmetry. This might look like a line of symmetry, but if you were to fold that, these corners would not match up here. So it only has 2 lines of symmetry. It should be the red and the blue. Determine if it has rotational symmetry, and if it does, what is the angle of rotation? Rotation means you can turn it and get the exact same image. Well, for us to get the exact same image here, we'd have to go all the way around. So this one would be a no. Therefore, you'd leave the angle blank. This one, all you have to do is rotate from here to here, and you get the same image. So it does have rotational symmetry. And the way you figure that out is 360, and we have 3 different pieces here. 1, 2, 3. So 360 divided by 3 is 120. So that would be our angle of rotation. Determine if it has rotational symmetry and if it has point symmetry. Point symmetry is a little bit different. Point symmetry is a type of rotational symmetry where you have a reflected across the origin image. All right. And so I'll give you an example. Here, the first question is, does it have rotational symmetry? And the answer is yes. So we can take this H and you only have to rotate 180 degrees and you get the same image. So yes, it has rotational symmetry, and the angle of rotation is, 180. Okay, point symmetry says this: if I have a point in the middle, is it possible each across from here, there's 1 point. If I flip that point across the origin, do I get the same point? Reflecting across the origin, the answer would be yes. At every aspect, if I take this point, reflect it across the origin, I get the exact same point, each and every aspect. This point, reflect across the origin. There we are. This point reflected across the origin. That has point symmetry, so the answer is yes. Does this have rotational symmetry? Means can you turn it less than 360 and get the same image? The answer is no. To get the same image here, you'd have to go all the way around 360. So if it does not have rotational symmetry, don't have to worry about that angle, and it does not have point symmetry. Circular dial has 8 equally spaced points. Point A is at the top of the dial. Suppose that the dial is turned counterclockwise. Careful, that directions, your instinct is to go clockwise here. So make sure you read the instructions counterclockwise. Okay, so that G is at the top. So we're taking G and we're going counterclockwise, which means this direction. How many degrees does this dial have to turn? Well, to figure out how many degrees total, you first figure out what is one wedge slice here. It's going to be 360 divided by 8, which is 45. So I know each of these wedge slices are 45. And for me to go from here to here, that's 1, 2, 3, 4, 5, 6, 45 degrees. So you have to turn 270 degrees counterclockwise.